You know that feeling, right? It's like pure magic. We type a simple command, something like "tell me a story," into a clean little box, and boom, out flows a story, an image, maybe even a solution to a really complex problem. The whole thing feels so abstract, kind of weightless, like it's all just happening somewhere up in the cloud. But here's the thing, that cloud is casting a shadow, a really, really heavy one.
Okay, so let's get real for a second, because behind every single one of those effortless AI replies is a factory. I'm talking a massive, humming, industrial-scale complex of servers, power grids, and cooling systems. This is the physical truth of AI. It's not some disembodied brain floating in the ether. No way. It's a machine forged from the earth, and it has an absolutely insatiable appetite. All right, first up, we're diving into the price of a thought. We're going to uncover the real material cost of intelligence.
So, what's the actual physical cost of a single AI query?
It sounds like a simple question, right?
But the answer, honestly, it's pretty staggering. We're going to break it down into 3 basic resources: water, energy, and the literal minerals that make the whole thing possible.
So let's start with water. Think about this. For every chat you have with a large language model, say about 20 questions or so, the data centers cooling those processors essentially drink a full bottle of water. Yep, 500 milliliters. That's just to stop these incredibly powerful machines from overheating. Now, just try to imagine scaling that up by billions of queries every single day. You start to see the hidden water footprint, and it is massive. And then there's the energy. I mean, just look at this chart. AI isn't just a steady consumer. Its hunger is accelerating like crazy. That huge spike you see there, that's not just a blip. It's the beginning of a total rewiring of our global energy needs. We're not just plugging in a few extra servers here. We are literally building an entirely new layer of power demand right on top of our existing world.
Okay, so how big are we talking? Get ready for this number. 1,700 terawatt hours. That's the projected annual electricity demand from data centers by 2035. And to put that into perspective for you, that is more than the entire current electricity consumption of India, a nation of 1.4 billion people. We are, for all intents and purposes, building a brand new, incredibly energy-hungry digital continent.
So where is all that energy actually going? Well, it's powering hardware that's built from some very specific and sometimes very rare materials. See, AI doesn't just run on code. It runs on gallium for its high-performance GPUs, tons and tons of copper for wiring, and rare earth elements for these super specialized cooling magnets. It turns out that intelligence is literally forged from rock and metal.
And this is where it gets really interesting on a global scale. This chart shows a critical vulnerability. The refining process for these essential minerals, it's incredibly concentrated. We're talking just a handful of places on Earth. And all of a sudden, controlling these materials isn't just about industrial policy anymore. It's about controlling the very foundation of our digital future. This stuff is literally redrawing the map of geopolitical power.
Okay, so we've got the raw materials. Now let's zoom out and see what we're actually building with them. Because it's not just a bunch of data centers. It's more like we're assembling Earth's nervous system, a global, planetary-scale computation machine.
You know, the theorist Benjamin Bratton, he has a name for this whole thing, the stack. And what's wild is that nobody really planned it from the top down. It's more of an accidental megastructure that's just emerged from all of our interconnected technologies. And here's the kicker. It's starting to develop its own logic, its own form of governance that operates above and beyond traditional countries.
So, the stack has 6 different layers, but they're all connected. Let's walk through them. It starts at the very bottom with the Earth layer. Yep, all those minerals and all that energy we were just talking about. Then you've got the cloud layer, the huge platforms like AWS and Google. After that comes the city layer. Think of all the physical fiber optic cables and cell towers wiring our world together. Above that is the address layer, which gives everything a unique ID. Then the interface layer, which is basically how we interact with it all, our screens. And finally, at the very top is the user layer. That's us.
Okay, but to make this planetary machine truly work, its nervous system needs a massive upgrade. And the leap from 5G to 6G? It's way more than just faster downloads on your phone. We're talking about a potential 50-fold increase in data rates, and a huge shift from a centralized cloud to what's called an edge cloud continuum, where processing happens everywhere, all at once. This is what creates a truly ambient, intelligent environment. So,
We have this massive planetary scale machine that's getting faster and smarter every single second. So the big question is, what happens when we start letting it make decisions for us? This is where we shift gears a bit, from the physical to the philosophical. We're going to explore a world where the algorithm becomes the ruler, and optimization starts to replace wisdom. This brings us to a really important new idea: algorocracy. Basically, it means rule by algorithm. Think about it. In a normal system, a decision is justified by a law, right? Something you can read and debate. But in an algorocracy, the justification is just, well, the model determined this was the most optimal path, and that's it.
And that's where the danger lies. I love this quote. The infrastructure of trust takes decades, even centuries to grow. You can destroy it in a single afternoon with a bulldozer. Imagine an AI tasked with optimizing traffic flow. It might decide the optimal solution is to build a highway straight through a historic neighborhood. It sees the efficiency gain, but it is completely blind to the unquantifiable stuff, the social fabric, the community trust, that it just bulldozes in the process.
What this creates is something called an intelligibility deficit. The why behind the big decisions that shape our lives, it just disappears into a black box. I mean, how do you argue with a model's millions of parameters? You can't. The reason, the why, simply vanishes. And when that happens, a huge part of our ability to govern ourselves just goes right out the window with it.
Okay, so we've gone from how society is governed, and now we're going to zoom into the most intimate scale you can imagine, merging with the machine, the direct integration of this technology with our own minds and bodies. It really feels like we're standing at a fork in the road here. On one path, you've got what's called weak symbiosis. This is where AI stays as a powerful external tool that just helps us do things better. But the other path is strong symbiosis. And here we're talking about things like brain-computer interfaces, where the tech is no longer just a tool we use, but an integrated part of who we actually are.
And let me tell you, that second path is an ethical minefield. Seriously. What happens to privacy when your thoughts aren't actually private anymore? What happens to your sense of self when part of your consciousness is synthetic? And who even gets access to these incredible enhancements, and what does that mean for everyone else? These are, without a doubt, some of the hardest questions we will ever have to face.
Okay, for our final section, we're pulling the lens all the way back out. We've gone from personal to planetary, and now we're looking at the ultimate stakes, that global red line. We're talking about the potential existential risks AI poses, and the absolutely desperate global race to get this right.
You really have to start with this incredibly sobering warning from Stephen Hawking himself. The development of full artificial intelligence could spell the end of the human race. I mean, that's heavy. The idea that we could lose control of a superintelligence isn't just a movie plot anymore. It's a very real possibility that some of the smartest people on the planet take very, very seriously.
And this concern, it's not just in academia anymore. It has officially moved into the halls of power. You've got leaders like the EU's Ursula von der Leyen openly saying that the window to act is closing, and it's closing fast. The tech is just advancing way more quickly than even the people who built it ever predicted.
And what's truly fascinating is the consensus that seems to be forming. This quote from China's Premier Li Qiang shows that the call for a red line in AI development is becoming universal. You have major world powers all agreeing on the basic principle. This tech has to be guided for the benefit of all humanity, not just for a small select group.
Which really leaves us with this final, crucial question. We are building the most powerful problem-solving tool in the history of the world. It can optimize for literally any goal we give it. But have we actually figured out how to teach it the difference between efficiency and wisdom? Between an answer that's correct and one that's right? Have we taught it what we as humans truly value? Because that, right there, is the challenge that's going to define our entire future.